Thanks, Venice. So the topic of this webinar is the common contour binning. The outline of this webinar will be first expose the principle of it, then see an application in OpendTect, and then we go further using what we can do using Syntrug before the conclusions. Right, so the common contour binning is a plugin which is available in the attribute and processing package, and also available as a standalone OpendTect plugin. So the objective of the common contour binning is to highlight changes related to the presence of hydrocarbon, so hydrocarbon-related seismic anomalies, and to determine, to localize gas water, gas oil, or oil water contacts. So the principle is quite easy. Basically, what you're doing is you're stacking amplitude along contours. So if there is very subtle changes, then you will highlight, you will enhance them. Based on the same principle, you have other attribute within OpendTect. You can you do the seismic feature enhancement, which is an ArcCLS plugin, and also the optical stack. Also, using as a same CCB feature, you have the local CCB, which is used to enhance 4D effects. And the pre-stack CCB will enhance AVO effects. So the local CCB is you will find it in the attribute set window. So here it is. And for the pre-stack CCB, in the CCB main window, you have the option analysis type. You can, by default, it's post-stack, but if you can change that to pre-stack. So this is how it looks for pre-stack. You see, you have the offset and the horizon in two-way time, the depth of the horizon. So that allows you to see the changes in the amplitude with the offset and the depth. Okay. So now we're going to see the application in OpendTect. So I give the hand to Paul, who is going to demonstrate that for you.
Denise, can you tell me when
yeah.
I'm the presenter?
Yeah, you can be now.
Okay, yeah. Okay, well, this is an application of CCB. It's an actual data set from somewhere in Asia. We're talking about a carbonate play covered by salt. This is top reservoir here, and if we look at this horizon in full, then we see a nice structure here in the middle. But if we look at the amplitude map at this top reservoir level, then we don't actually see an amplitude anomaly that is conformable with structure. So nevertheless, we're going to see if we can do an enhancement of all these potential amplitude effects caused by the hydrocarbons by stacking along these contours. And we do that by launching the CCB application. First, we select from which horizon we are going to do this. That will be the top of the reservoir. We're doing the post-stack mode in this case. Input our seismic, and we're going to make a sub-selection. And actually, I should show the sub-selection because we're going to stack within a particular contour. So we're first going to create a contour, and then we launch the CCB application. So here I'm picking my sub-selection up. My polygon is the top of the structure. And we can specify an interval relative to this horizon that we will going to extract, and also the contour binning stacking interval we can specify. So I'm now actually getting all the traces within this polygon interval. We're sorting them according to their contour level, and we get this histogram of all the traces that have been selected. From left to the right we see the different contour depths. Now the first thing I can do is I can create a flattened CCB stack, flattened around this horizon, but what I will do is I will tilt it a little bit so that we can actually also better visualize potential flat spots. Flat spots in this tilted display should also be flat. This is my top horizon, and if we look at the amplitudes along this structure, then what we see here is we see some low amplitudes, then these amplitudes step up. We have an intermediate level of amplitudes, and then we have high amplitudes. So we see 3 steps in the amplitude behavior along the top reservoir level. Now this could be interpreted as a potential gas cap with a gas oil break somewhere over here. Then we have the oil lag, and we have the oil water break somewhere around this position. Now there are some other options that I will just display here. What we also can do is we can analyze this directionally. We will then get in a number of segments all the amplitudes that are collected within our polygon, and we see the amplitude behavior, and we can stack only in a number of segments in a certain direction. And the other thing we actually can do is we can write out all these stacked traces again along these contours, so that we create a new cube of data, and that new cube we can then analyze. We can create amplitude maps from this. We can display cross sections or analyze it in different way. Now let's look at the actual results. Here we have our polygon area again, and now we have created a cube with all the stacked traces. And if I now look at the amplitude behavior along that new cube, then I see here my low amplitude response at the crest of my structure, and the second break of my amplitudes are from red to blue colors, more or less. Now that is interesting, because if I now further analyze this data and also do a seismic chimney analysis, then what I actually see is this. So in a seismic chimney analysis we have used our pattern recognition technique to visualize vertical disturbances in the seismic data, and these vertical disturbances can often be interpreted in terms of fluid migrations. What we see here is that we have a lot of activity going on along this trend, which is a fault trend just below our structure. And our second break in the amplitude response, which we thought could be an oil-water contact, is actually coinciding with this spill point. So that's very interesting observation, because we now have an amplitude anomaly that is coinciding with the actual spill point. The second observation we can make from this chimney analysis is that we don't see any chimney activity above the structure itself, which means that the top seal is intact, and we only have leakage along the flank. As you all know, we have done a lot of work in this domain, chimney analysis, and this is the situation that we have. We have enhanced an anomaly using our common contour binning technique with low amplitudes at the top of the structure, and a second break in the amplitude response, in this case along the yellow-blue line, and that coincides with the chimney analysis on the flank. So we have leakage along the flank, good top seal, leakage along the flanks. We can now classify this using our classification scheme, and this has been published widely. based on approximately 150 different studies that we have done. And in this particular case, we would rank this particular configuration of seismic chimneys, faults and structure as a fault flank trap. So what we see is we have chimneys along a fault system, we have up-dip potential, and we have an amplitude anomaly that is coinciding with the spill point. So that is really a very, very hot prospect that you would always like to drill. And with that, I would like to give back to Claire to talk about SynthRock and how you can actually confirm these type of observations, especially the panels that we make with CCB using SynthRock analysis. Claire, over to you.
Thank you, Paul. Thank you, Paul, for the demonstration. So before switching to the application in SynthRock, I want to just summarize some key points about CCB. So the CCB will make sense only if you have a structural trap. So if you have for lithology trap, that won't work. You need to have a structure. When you look at an amplitude anomaly, there is so it can be a fluid, but it can also be a change due to rock properties. So you have to always to keep in mind that there is these two possibilities. So it's sometimes you have actually when the break in the amplitude change is not that clear, you are in a case where it's not, you don't really know what's going on. So in any case, you need to go a bit further to really characterize your anomaly. So in general, CCB, well, you should always confirm if it's the presence of your hydrocarbons using a different another method. So you can use that. That's what we do when we do with SynthRock. So SynthRock is the forward modeling package in OpendTect, so for pseudo-well modeling and probabilistic inversion. So when you do a sensitivity analysis, you change one parameter, and you analyze the effect of this parameter on your synthetic seismic, on your seismic response. So that allow you to characterize. In this case, if you do the parameter you change is the water saturation. Using fluid replacement, you can see you can characterize the your seismic anomaly. So what kind of if it's actually fluid or if it's lithology effect, and which type of fluid it is. But this has been explained more broadly in the previous webinar about rock physics modeling using SynthRock that has been put online this year. So just quickly in OpendTect for the where you can find this how you can do this forward modeling. You go into the SynthRock module, so SynthRock. You choose the profile mode. So here I have already one have been saved, so it's based on the FTD mode, because in the previous survey we showed we don't have well data. Okay, so it's just loading and generating the elastic model and the synthetic. So here's my horizon, which is the top of my reservoir. So I'm just going to zoom a bit. Okay. So here is the my hydrocarbon column. So we're now going to do the fluid replacement. So this has no fluid, and see the impact here on the synthetic seismic of replacing. So here what the fluid is gas. So here I have this icon, apply fluid replacement. So the parameters have been set up before. So I'm not going to go into the details here. If you want to see more about it, you can check on the previous webinar. So it's rather quick. Okay. So here is the impact of replacing the fluid replacement with gas. So I can see the impact on the amplitude, and I can see clearly a flat spot. So this allows you, when you have your well in your an seismic anomaly, you can really determine and characterize completely your seismic anomaly in detail using Syntroc and 4.1 modeling. So to conclude, in case if you have a structural trap, then CCB is a quick technique to highlight your seismic anomalies and to determine fluid contact with a quite good accuracy. In case of uncertainty, using Syntroc, you can completely characterize your seismic anomaly and it's know if it's due to a fluid presence or due to a lithology effect. So this webinar has been recorded and will be available in a few days on the link shown here. And you can download the software OpenTect also on our OpendTect.org website. And if you want to request some licenses, you can always send an email, and we will consider that. So thank you for your attention. And if you have, we're going to now answer your questions. And if later on you have questions and comments, send us an email at the email address support@opendetect.org.
Okay, thank you very much, Paul and Claire. And now it's time for Q&A session. So please, if you have any question, you can raise your hand or you can type your question. Okay, does that mean that everything was very clear? That's very good. We're still open, though, for any questions. Okay, here's a question from Ms. Okay, Arno, I sent you a question from Steve Clausen.
Yes, let me read the question. The question is, how do you use it in the optical stack method? The answer is that the optical stack method should be looked as, well, not so much an equivalent to CCB, but the predecessor of the CCB stacking technique. So it's not like you have to chain these two methods. It's that you'd rather use one or the other. And in general, I would say that the CCB will always have the advantage, the CCB will always have the advantage over the optical stacking. The only reason where I would see that optical stacking would still be used is when you don't have interpretations, because you can apply the optical stack on a random line. But similarly, you could also argue that you can apply the local CCB also along a single line, but although this one also requires an horizon. So in summary, optical stacking only if you don't have horizons. In all other cases, I would recommend to use common contour binning.
Okay. Okay, thank you very much, Arno. Okay, any more questions? All right. With this question, we will end our webinar, and we thank everyone from the attendees. And as Claire said, you will have a link coming to your email with the recording, and it also will be in our Facebook page and in our LinkedIn page. And we have a webinar. If you are joining us for the first time, we have a webinar every month, and you will receive an invitation with this webinar. Thanks everyone, and hope to see you again. And if you remembered any question after this webinar, you can just feel free to email it to us anytime. Thanks, Paul, Arno, David, and Claire.